I'm Biff Turkelman. You've seen me in such fine quality, epic chemistry review videos such as Canu G CHem Crash Course C4 Part 1, and it's time to do the review now. Okay, so here's Chapter 7. Ignore the Part A. It's the whole thing. So when we look at bonds between the atoms that are formed, what's actually forming the connection between two atoms? Is it the protons, the neutrons, the electrons, or the valence electrons? Yes, the valence electrons, because you know you have the other electrons underneath that outer layer that we call the valence electrons, and they're saying, yo, hip hop, hooray! They're having their own block party, right? Yeah. So we talked about sigma bonds and pi bonds. It's another way of explaining how that the valence electrons between the atoms connect. So what types of bonds do sigma bonds form? They're actually involved in all of them, the single, the double, and the triple. What you find the sigma bond by itself alone is in the single bond, okay? It is with the double and the triple, it's there, and that's where you're going to find the pi bonds in there. Pi bonds are in the double and the triple. You won't see pi bonds in the single. Okay? So pi bonds, there's one pi bond, one sigma bond for the double, two pi bonds, one sigma bond for the triple bond. Okay? That's how it works. So if we look at the strongest types of bonds, the triple bond is the strongest. Then the next one that's not as strong is the double bond, and the weakest one, the weak sauce, it's the single bond. All right, let's move on. So on the test, I can sit there and put a question like, examine the picture below, and here you go, here's an example. How many sigma bonds exist in this molecule? Well, what do we know about sigma bonds? We know that they exist in the bonds between atoms, and we know that they're in single, double, and triple bonds. Now, are unshared pairs of electrons sigma bonds? No, that's because they're not connected to anything. They're just by themselves. Okay? So these here are single bonds. Each single bond has one sigma bond. So the correct answer is 2 on this one. All right, let's look at this one down here. So here is CO2, and examine the picture below. How many sigma bonds exist in this molecule? Well, what do we know about sigma bonds? We know that there would be one in a single bond, one in a double bond, one in a triple bond. Okay? So again, unshared pairs of electrons don't count. So that would be 1 and 2, but you also have one pi bond here, one pi bond here. So you have a single bond and a pi bond. When they get together, they form the double bond. Here is your single bond. Here is your pi bond. When they come together, they form a double bond. When you have a double bond, that you have your sigma and pi, and you get another pi bond over it, form over, and there's your triple bond. Yeah, that's how it works. So then, of course, the next question is, well, what types of bonds would you find pi bonds a part of? Single, double, or triple? Well, actually, you'll find them in the double and the triple. You won't find pi bonds in the single. Okay? Explain the Vsepr theory. Okay, valence shell electron pair repulsion theory. The idea is that the electrons are pushing away from each other. They are, in fact, repelling. Okay, this is specifically the valence electrons, not the electrons underneath that outer layer, because those underneath are going, hey, house party. They don't care. They're not involved in the bonding. They really are not. Okay? So remember the idea about the Vsepr theory. It's the bonding electrons or unshared pairs of electrons on the outside of the atom that they push away from each other. Okay? That would be a fairly important idea. Okay? The viewer went a little dim on me. Okay, let's go on here. So what can we say about pairs of electrons? Do they attract or do they repel? Okay, so somebody asks me, hey, Mr. Canu, what's repel? And you're busy talking to your friend right now and you miss out on it? I'm not answering that question on the test because it was in the review. It was in your online quiz. So you should know repel. Get away from me, okay? So, two bonds on the same atom will try to get as close to each other or as far away as possible. Okay, this might explain a few things about the shapes of molecules. They're going to try to go as far away as possible. Remember, I had you guys in two groups, and I said find the places in the room where you are as far away from the other group. It was so far away. Okay, so you want on opposite ends. Okay? Alright, so if we have a lone pair of electrons and a bonded pair of electrons, we'll push away. Canu, what are you saying if I say here's a carbon and here is an unshared pair and here is a bonded pair with something? Guys, they're going to push away from each other as much as they can. Alright? If you have oxygen, here's your hydrogen, okay? See these bonded pairs? They're going to push away from each other. The bonded atoms, the bonding electrons and the unshared electrons are going to push away from each other. And then, of course, the bonded electrons here and the bonded electrons here, they're also trying to push away from each other. And some people will be saying, so, and they get some drool coming out of the side of their mouth. This is where you get the shapes of molecules. Structure tells you what it does. Structure determines function. For example, I have a cup. It contains water, okay, and some ice. But it's in the shape of a cup. So the shape of the cup tells me, hey, I can put water and ice in here safely. Then I have a straw. The shape of the straw tells me what I can do with it. Oh yeah, nice and cold, like how I serve my pop quizzes. Let's go to the quick guide of molecule shapes, okay? We spent a lot of time, I had you guys build models in the lab, models of everyday molecules that people have used, like Tylenol, adrenaline, Motrin, rubbing alcohol, okay? So here is a quick guide. Two atom molecule like HF, HCl, HBr, NaCl, they're always going to be linear. Always. Okay? Well, what about the three atom molecule? Like CO2 or H2O? A little more tricky because it could be linear. What do we mean by linear? Linear, if I look at HF, linear means straight line. Okay? That's what it means. Just like in that math term when they talk about linear equations. They're talking about a line equation. But for us here, linear means a nice straight line. Okay? That's pretty important. Three atom molecule. They could be linear or bent. Oh, snap. How can you tell? That'll be an important thing. So let's take a look at it. So three atom molecule could be linear or bent. Let's look at something that is linear. Alright, so I have carbon, oxygen, oxygen. Now, really? Okay, fine. Now it's decided to go wacky on me. Alright. So,
here we've got CO2, and what is up with that? Well, keep in mind that with CO2, it is a linear molecule. It's a straight line. You would say, well, how can I tell? Well, let's draw the water molecule for a moment. And it's, again, the idea is it should be useful that you should know about the shapes of molecules. That probably would be good. Now, look at CO2 and H2O, all right? Each has 3 atoms. That's they got in common, all right? But one of these, one is bent. The water is bent. Everybody knows that the water is bent because they know it as the Mickey Mouse molecule, okay? Okay, Disney, I'm sorry. I'm not trying to infringe on your trademark here. Okay, thank you. All right. Look at the center atom. Here, carbon. Here, oxygen. Look at the center atom. What do they have? What do they have that's similar? Some people would say, well, nothing. Not true. You've got bonds. You've got a bond here to an atom, a bond here to an atom. So here, this is bonded to 2 atoms. This is also bonded to 2 atoms. So, ha! There is something they have in common. What else? Well, these are double bonds. Now, how many electrons go in the double bonds? We know that it's 1 pair, or 2 electrons for a single bond. In a double bond, it's 2 pairs, or 4 electrons. So that means 4 here, 4 here. That forms the double bond. And are there any unshared pair of electrons here? No, there isn't. But wait a minute, that doesn't explain why is it linear. Sure it does. Earlier we talked about what is it that those bonded electrons will do. What do electrons do? They push away from each other, right? 2 groups. You've got 1 group of electrons here, 1 group of electrons here. Now, look how far apart they are. They are so far away. Okay, 180 degrees. So, it's straight, it's a line, it's linear, because these electrons, there's no unshared pair of electrons here. It's a straight line. Let's go over here. Over here, you have got 1, 2, 3, 4 unpaired electrons here. And what's happening? The use of the force, Luke. So what's going on? Okay, so here they go. They're pushing down. They're pushing down. It's part of the system. It's pushing it down. I'm telling you. Okay? And these guys are pushing they're pushing each other as well. And what's happening? What is stopping these? So here's your line, right? Here's your line. And what's stopping it on the water from going down like this? Where they're together. Or maybe I'll go up. Hey, on Snoopy. All right. So it's up in the air. Okay? What is stopping that from happening? You have electrons in these bonds, and when they come close together, hey, get away from me. And thus, it's bent like this because of all the resistance between the atoms themselves, between the electrons themselves. Okay? Okay, let's keep going. I'm going to erase this. And again, I'm explaining it to you. I'm going to put this up on YouTube because, yeah, I need the clicks! I need the viewership! No, actually, I'm at a big whopping 171 subscribers. So for all the haters out there, handle it. Okay. So, what about the 4-atom molecule like NH3? When it's 4 atoms, it's going to be a pyramid. Or it could also be a flat triangle. It could be. Planar, triangular, planar, or the flat triangle. So let's take a look at this for a moment. Here's NH3. So here's our nitrogen, and we have here hydrogen, hydrogen, hydrogen. And if you notice, it's bent downward. What could possibly cause that? Once again, unshared electrons, forcing it down. They have the influence. It's the system, man. It is keeping the hydrogens down, and the hydrogens are not going to go slamming into each other because they're also pushing away. So what you're seeing for the shape, guys, is the equilibrium of how these guys are pushing and shoving. That it's a compromise because not everybody is getting what they want, which is to be as far away from each other as possible. Okay? So that's pyramidal. Now, what about triangular planar? What about triangular planar? Triangular planar is a nice fancy way of saying flat triangle. And a flat triangle, great example would be barium trifluoride. You're looking at it top down. It's a flat triangle. How come? Well, barium is, not barium, it's boron trifluoride. Sorry guys, boron, okay? Okay, I got a technical on me. I'll deal with it. Some of you b-ball players out there, and we won't mention names, you know what it's like to handle technicals, right? Okay, so I got a technical on me. So what's going on here? It's boron trifluoride. Boron is a smaller atom, so it breaks that octet rule. It's smaller, it doesn't take as many electrons, and because of that, all that the fluorines have to do is worry about separating from each other, which in geometry, that 360-degree angle thing, they're split at an even 120 degrees each. Now, going on with this, I'm going to erase all of this and move on, because I've got about 17 minutes left, roughly. Or no, I don't have 17 minutes left. Okay, so what about the 5-atom molecule? Well, that's going to be tetrahedral. Wait, what do you mean by tetrahedral? Well, if I look at it, oops. C is in the middle, and you got 1, 2, 3, 4. H, 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 H. Good old methane gas. Okay, good old methane. Okay, we produce this puppy all the time. Cows, it comes out. Well, we won't go there. It's just biology, man. Just think about the biology days. So this is an example of a tetrahedral. There are no unshared electrons. If you did, then that would change the shape of it. And I'm not going to do that to you. Okay? So the shape of the molecule tells us what the molecule is going to be doing. Okay? All right. You know what? I'm almost out of time here, but I'm going to conclude this one here as part 1 of the review, and then I'm going to do part 2 shortly. So, I'm off to my halftime. See yas!